everyone and welcome back to the new video of this channel. So today I will be solving a problem which is maximum number of points with cost Leetcode 1937 problem. So let's see the problem statement. So problem is saying that we have given a n cross n matrix points starting with the 0 point. You want to maximize the number of points you can get from the matrix. To gain points, you must pick one cell in each row. Picking the cell at coordinate r, c will add points of r, c to your score. It means I can only take 1 point. I can only take a single cell in a single row. So, however, you will lose points if you pick a cell too far from the cell that you picked in the previous row. For every two adjacent row, r and r plus 1, where this is the condition, picking cells at coordinate r1, c1 and r plus 1, c2 will subtract absolute value of c1 minus c2. It means if I am picking the element from the different rows, different columns actually, you can see this example actually. The first condition is I can only pick one element or one cell in a single row. So it means if I am taking this row, so 1, 2, 3, I have to maximize my points. So for maximizing the point, I have to take the maximum element. So I am taking this 3 from the first row. In from the second row, I am taking 5, and from the third row, I am taking 3. So our answer will be 3 plus 5 plus 3. Now I have to subtract the absolute value of different columns like C1 minus C2 because here I am taking the element from the first row which column is 0, 1, 2, second column, and from the second row I am taking the element which has a column 0, 1, first column. So the absolute difference between these two will be 2 minus 1, which is 1. So absolute difference of 2 minus 1 plus the absolute difference of 1, this is the first column and this is the zeroth column. So 1 minus 0, which is 1. So the this will be 1 plus 1, 2. So I have to subtract 11 minus 2. I have to subtract 2 from the answer, and now answer will be 9. So now let's take this example also. So I can only take a single element from the row. So after taking single element, my answer will be 5 plus 3 plus 4. Now it will be 5 plus 4, 9, 9 plus 3, 12. So 12. Now I have to subtract the column different columns because this is the condition. If I am taking the element from the different rows, I have to subtract the columns also. So the column is, if I am starting with 0th index, the column will be 0 and 1. So this is the first column. So first element I am taking from the first column, and second element also I am taking from the first column. So 1 minus 1, it is 0. So no mean, it means 0 0 को माइनस करेंगे कोई दिक्कत नहीं है, ठीक है. Now third element I am taking from the zeroth column. So 1 minus 0. So which is 1. So after subtracting this 1, my answer will be 12 minus 1, which is 11. So 11 will be my answer. So basically what we are doing is we are just traversing a row and we are finding out the maximum element of that particular row. And after finding out the maximum element, I am adding that element into my answer और पॉइंट्स ऑफ आई ऑफ जे. सो उसको गेट ऐड कर देंगे और आफ्टर दैट I have to subtract the different columns also. If I am taking the element from the first row and then again I am taking the element from the different row, I have to subtract the different columns also. So it means absolute value of C1 minus C2. So now let's see how we'll approach this problem. So let's imagine I am at this index or I am at this point like 5. This is a 5. If I am starting from the 0th index, this will be dp. I am taking like vector of 1 comma 1. This is a 1 comma 1 point, 0, actually 0 0 0 1 0 2 1 0, and this is a 1 1. So if I want to reach this element, I can come from this 1, I can come from this 2, and I can come from this 3 also. So we have three choices. Either I can come from 1 or 2 or 3. So we have three choices. So if choices is there, then we can use recursion, and for optimal approach we can use DP. So now we know we'll use dp here. So let's see how we'll use dp here. So now for this you can follow these comments also, but I'll explain you by myself. So this is the code. explanation or approach. So for this, I am taking a array which is a 1D array. Initially 1D array 81526, and I have to find this one a of I plus a of j plus I minus j. It is the same like the previous question. This question it is same like this question. It's a 2D matrix, but it's a 1D matrix or 1D array. So I can write this as a of I plus I and plus a of j minus j. So this is a way to write this condition. So now this is the code, and now let's go on to the original problem. So original problem is this one. If I have given this matrix and I am at this point, if I want to reach this point, I can come either from 1 or 2 or 3 and again 1. So we have four choices, so that's why I can use recursion because we have choices. And for optimal approach I can use dp. So let's see. If dp of I of j, dp of I of j is this point. If I want to reach this point, so I can come from this point, so it will be dp of I minus 1. It's a I comma j point, so this point will be dp of I minus 1 comma k. K is coming from 0 to m minus 1. It means dp of I minus 1 comma k minus 1. Oh sorry, j minus 1, then j, then j plus 1, then j plus 2. So k is coming, k is going from 0 to m minus 1. That's why I'm taking this k plus points of I of j because I have to add the points also. So points of I of j. Now I know if I am coming from the different rows, if I am taking elements from the different rows, I have to subset the columns also. So that's why I am subtracting the columns. So that's why minus of absolute value of j minus k. Why I am taking this k because k is going from 0 to m minus 1. Here k is moving, and this is a m size column or m size column. So that's why I am going from 0 to m minus 1. So this is the condition, but here you can see we have three variables I, j and k. So k is going from 0 to m minus 1, so it will be something like big of n into m into m. That is not a optimal solution because big of n into n, it will give me a TLE because n comma m is going from 10 going to 10 raised to power 5. Actually let's see the sub constraints also. N comma m is going up to 10 raised to power 5, so that is not optimal. So I have to optimize the solution also. So now we know ki here k is going from 0 to m minus 1. So what I can do is I can take a left part or right part. So if j is greater than k, j is greater than k, it means this wala part. I am at this index. This is a j. So if j is greater than k, it means k can be this one, और अगर इससे पहले भी कोई elements पड़े होंगे तो that can be included because the condition is j is greater than k. So I can't take this 2. I can take 1 and इससे पहले वाले element. So the condition will be dp of I minus 1 comma I minus 1 of k plus points of I comma j because I have to add the gain. Now I have to subtract the absolute difference also. So the absolute difference will be something like j minus k because j is greater than k. So minus of j minus k. After rearranging all the elements, it will be something like dp of I minus 1 of k plus k because minus minus this will be plus plus k plus this is the gain points of I comma j minus j. It will be something like this condition, this a of I plus I. So it is a something like this condition, same as a this condition. Now our case is, now my second case is if my j is less than k. J is less than k, it means k is greater than, k is greater. So k is greater means now k can be 3 or 1 और इसके बाद वाले element because k can't be 2 or k can't be 1. K is greater than, because we know कि k is greater than j, so j वाला element is this one, and that's why I can take only 3 or 1 or after the element, after all the elements. अगर ये matrix बड़ी भी होगी so for in that case also I can include the elements also. So now my condition will be dp of I minus 1 comma k plus this is the gain points of I comma j. Now I have to subtract the absolute difference also. Now k is greater than j, so it will be minus of k minus j. after rearranging this equation, so dp of I minus 1 comma k minus k plus points of this one plus j. So it is same like the this equation. So now let's see the time and space complexity. So time complexity will be big of n into m because we are just traversing the array. You can see here k is going from 0 to m minus 1 and I is going from 0 to n. So it will be something like big of n into m, and space complexity is big of m because we are taking the space of dp. So that's why big of m is a space complexity, and that is the optimal approach for this. So now let's see the code. So coding part is very simple. Firstly, you can see this these points also for understanding purpose. I have written this. So for coding part, what we are doing is we are just initializing the size. This is the n is the showing the row and m is showing the column, and we are just taking the dp 2D array, or you can say dp 2D mat for finding out the 2D matrix, and we are initializing the 2D dp by using the points of 0 comma j. Now what we are doing is we are here we have two cases. Like we are firstly going from j is greater than k. It means we are going from 0 to left, like we are going in left direction, or in second case we are going in right direction. So firstly we are going in left direction. So for that I am creating a left max and I am initializing with 0. Now what we are doing is left max of 0 equals to dp of I minus 1 comma 0, and now k is going from 1 to m. You can see here also k j is greater than k. J is greater than k. It means j is going from 1 to 1 to m. And now we are finding out the same condition. Left max of k equals to maximum of left max of k minus 1 comma dp of I minus 1 comma k plus k. And as same as, and now I am going in right direction. Right direction में जाने के लिए क्या करेंगे, बैक साइड से ट्रेवर्स करेंगे. So this is the same loop. By using this I am initializing ending element and going from the back. Now I have to update my dp also. So dp of I of j now will be points of I comma j plus maximum of these two. So this will give me the, this will update the dp array. Oh, and finally, I will return this dp array. So for returning this, I have to initialize my answer. So long answer equals to 0, and I am applying a loop that is going from 0 to m because m is the size of the column. So I, because ultimately I have to go in column also. So that's why I'm going in column and I'm taking initially answer equals to 0, and I am applying a loop, and I am updating my answer array. Answer will be the maximum answer comma dp of n minus 1 comma j. So and after that I am returning my answer. So that is a simple code, and if I run this and let's see is this will work or not. It is working perfect. Let's submit it. Now you can see it is getting accepted. So here the time complexity is big of n into m because you can see here this loop is going up to n, and this loop inside this loop it is ultimately a nested loop. K is going from 1 to m, so it will be something like big of n into m, and the space complexity also will be big of n into m, or we can reduce the space also, that will be ultimately big of m. So this is our code, and if you find this helpful, then please like, share, and subscribe quickly. Bye.